Your dreams are lying to you about color. What if your dreams are trickier than you think? Do you dream in color, or are your dreams lying to you? Most of us probably assume that our dreams look just like real life, vivid skies, bright faces, warm sunsets. But here's something strange. If you'd grown up a few decades earlier, you might have said your dreams were in black and white, and you would have meant it literally. Entire generations once believed that their dream worlds had no color at all. So what happened? Did our brains suddenly evolve to invent color while we slept, or did something else sneak into our subconscious? This is one of those mysteries where psychology, culture, and neuroscience all blur into one another. The story starts with a question that sounds simple but isn't. What's the true color of a dream? For a long time, scientists thought they had an answer. Surveys from the early 20th century showed that most people described their dreams as entirely grayscale, flat, shadowy, like an old silent film. To them, colorful dreams were rare oddities, sometimes even considered symptoms of emotional instability. The phrase technicolor dream was actually used to describe something unusually vivid or strange, almost unnatural. But fast forward a few decades and the story flips. By the 196s, scientists were suddenly hearing the opposite. Now, most people were dreaming in full color again. Red, blue, green, the whole spectrum. It's as if someone had taken the paintbrush back to the human imagination. Why did that shift happen so suddenly? One clue lies not in the brain, but in the living room, right where those bulky black and white televisions sat. See, until the 195s, almost every moving image people consumed was monochrome. Movies, TV shows, the news, all projected the world without hue. But when color television arrived, people's descriptions of their dreams started to change. More households got color screens, and more dreamers began reporting color dreams. It's almost too perfect to be coincidence. It raises a wild possibility. Could what we watch while awake rewire what we see when we sleep? That's the mystery at the center of this episode, and it forces us to question how much of our internal reality is really ours. Maybe the color in your dreams isn't an artifact of biology at all. Maybe it's a reflection of culture, of what our eyes absorb day after day. It's a possibility that makes color itself feel like a language our brains learn, not something they were born fluent in. Of course, there's another side to it. Neuroscientists have found that the brain regions responsible for color perception, the ones that fire up when you see a red apple or blue sky, don't entirely shut down during sleep. That means the biological machinery for color is still running. So maybe our grandparents didn't actually lose color in their dreams. Maybe they just stopped remembering it. Maybe their brains filtered it out long before the memory surfaced in the morning. As we'll see, this mystery lives at the intersection of two forces, one cultural, one neural. On one hand, there's the psychology of memory, which can alter or erase details every time a dream gets recalled. On the other, the influences of media and perception that shape what the dream feels like in the first place. Together, they blur the line between what's experienced and what's remembered. So tonight, when you close your eyes, here's the question to keep in mind. Are your dreams truly painted by your mind, or are they tinted by your screen? Over the next few minutes, we'll trace how the brain constructs color while we sleep, how 20th century technology managed to drain it away, and why your subconscious may still be taking visual cues from an invention as ordinary as a television, the great dream color divide. Here's where the story really splits in two, because the color of your dream depends on when you were born. For people who grew up before the 196s, it's surprisingly common to say, "I mostly dream in black and white." But anyone born after the rise of color television will almost always insist their dreams are vividly colored. We're talking an entire generational divide, not in eyesight, not in genetics, but seemingly in perception itself. How can that even happen? Let's rewind to the 194s, when researchers first started asking the question seriously. In 1942, psychologist W.C. Middleton conducted one of the earliest large-scale studies on dream color. He surveyed college students and found that about 70% said their dreams were black and white most or all of the time. Only around 10% said they often dreamed in color. To the scientific community of the era, that seemed definitive. Dreams, it appeared, were mostly grayscale, and that belief took hold. For decades, the idea of the black and white dream became the accepted truth. Even pop culture echoed it. References to dreams were spoken about like old movies, quiet and colorless. In fact, some researchers at the time went so far as to describe vividly colorful dreams as signs of emotional disturbance. They called them technicolor dreams, borrowing from the film process that had just begun painting movie screens in bright hues. The term didn't sound flattering. It implied that color in dreams was artificial, exaggerated, even suspicious. Think about that. The human mind naturally sees color all day, yet mid-century psychology framed colored dreaming as the exception. That's how deep the assumption ran. Then something odd happened in the 196s. Studies in the US and Europe found that most people now describe their dreams as full of color, light, and texture. In fact, when subjects were woken up in the middle of REM sleep, more than 80% reported seeing color clearly. It was as though, in only a few years, the sleeping human mind had repainted itself, and yet nothing about human biology had changed. So what did? Here's where Professor Eric Schwitzbill stepped in. In the early 200s, he decided to revisit those historical dream studies to see whether the data had really shifted, or if something else explained it. When he replicated Middleton's survey in 2001 with modern college students, he found almost inverse numbers. Only about 17% said they rarely or never dreamed in color, while over half said they saw color frequently or very frequently. That's a complete reversal of the 194's picture. The human brain didn't evolve in 50 years, so the answer had to lie somewhere outside of biology. The strongest clue came from Eva Merzen's 2008 research at the University of Dundee. She found that people who'd grown up watching black and white television reported more grayscale dreams than those raised entirely in the age of color screens. The link wasn't just casual, it showed up even when participants were asked to record their dreams immediately after waking, reducing the chance of memory error. According to her data, exposure to black and white media before about age 11 was a strong predictor for later grayscale dreaming. In other words, whatever visual world shapes your early imagination may leave a permanent mark on your dream palette. So picture that. For generations raised on black and white movies, newsreels, and TV drama, the monochrome imagery of waking life became part of the default visual language of dreaming. It's not that their brains couldn't see color. After all, they saw it in real life. It's that their nightly imagination was scripted using the imagery most deeply etched into memory. Those flickering silver shades of television became templates for dream construction. The timeline backs this up perfectly. In the early 190s, cinema was exclusively black and white. Then, between the 193s and 195s, massive audiences spent hours every week soaking in monochrome storytelling. By the time color film reached mainstream households in the mid-50s or 60s, the collective imagination had already absorbed decades of grayscale aesthetics. But as color screens spread, something fascinating happened. The generational dreamscape brightened. The return of color in dreams mirrored the rollout of color television across the country. By the early 197s, when most households had full color sets, the majority of people once again claimed their dreams were vividly colored. The timing is almost uncanny. This pattern doesn't just show up in Western countries. Schwitzbill's team later replicated Middleton's style of questionnaire in China, comparing groups with different childhood media experiences. People who had grown up mainly with black and white broadcasting described dreams much like those 194's Americans, mostly devoid of color, while younger participants who'd always watched in color reported colorful dream worlds instead. The results suggest something universal about how media consumption interacts with the dreaming brain. And yet there's another layer to it. While media exposure clearly plays a major role, not every black and white dreamer grew up on black and white TV, and not every color dreamer lives in a bright modern media bubble. That means cultural influence might not be the full story. Researchers suspect that what changed wasn't just what people were exposed to, but also how they were asked about their dreams. Remember, those early studies relied on long-term questionnaires filled out long after the dreams had faded from memory. Later research used laboratory observations and immediate reports, cutting out a lot of distortion. It's possible the dreams were always colorful, but the way we documented them drained the color out. Still, even accounting for methodology, the timeline of television history fits almost too neatly to ignore. The brightness of our dreamscapes seems tethered to the brightness of our screens. The gray dreams of the 194s weren't signs of defective imaginations. They were snapshots of a cultural environment steeped in black and white imagery. For decades, the world itself, as people most vividly saw it, came through a gray filter, so it's hardly surprising their inner cinema played in the same palette. And that's where the line blurs between technology and psychology. When the external world changes its tone, so does the internal one. Dreams mirror what we experience most consistently. So when the world screen shifted from monochrome to color, our collective subconscious quietly followed suit. But as we'll see next, Even that external influence can't fully explain why color sometimes disappears from our dream memories. Because beneath all the cultural layers, there's a biological system doing its own filtering, one built deep inside the brain. How your brain actually sees color. To really understand why some dreams lose their color, we've got to zoom in on how your brain sees color while you're awake. The process is surprisingly mechanical. Tiny photoreceptors in your eyes, called cones, respond to specific wavelengths of light. Some tune in best to red, others to green, others to blue. From the moment those signals hit your retina, your visual system starts building the entire color world you experience. It's the first step in a chain that stretches from the back of your eyes all the way to deep regions of your brain. Those electrical impulses travel through the optic nerve to the thalamus, which acts like air traffic control for sensory information. The thalamus decides what gets through to consciousness and what doesn't. From there, information is projected into the primary visual cortex, often called V1, where the raw data of light and shape become organized patterns. V1 sorts out edges, movement, and general contrast. But color itself really comes to life in a nearby region called V4. That's where the brain transforms wavelength into perception, converting physics into the feeling of red, green, or blue. The image doesn't just appear. It's constructed through layers of interpretation. And color isn't just a visual extra. It's tied to emotion and memory. Your amygdala and hippocampus light up right alongside those visual areas. That's why a red stoplight feels urgent and a soft blue evening feels calm. Color encodes emotion into experience, and the stronger that emotional imprint, the more deeply it gets filed into memory. When you think back to your childhood bedroom, you might not recall the furniture in detail, but you probably remember what color the walls were. The brain uses color as shorthand for meaning. Now here's where it gets interesting. When you fall asleep, that entire network doesn't just power down. During REM sleep, the stage when most vivid dreaming happens, your visual areas, including V4, spark back to life. EEG and fMRI studies show that neural patterns for color perception still echo through the visual cortex even with your eyes closed. It's as if your brain keeps projecting images onto an internal movie screen, but without new input coming from the outside world. The camera is off, but the projector is still running. Still, not every signal makes it through. The thalamus, remember, is also the brain's sensory gatekeeper. While you're awake, it constantly relays sensory data from the eyes to the cortex. But during sleep, it changes its role. It starts filtering, suppressing most external input, so you don't wake up each time a car passes outside your window. It's selective silence. However, that same filtering might apply internally too. The brain could be muting certain visual channels while it builds dream imagery, letting emotional and conceptual content dominate over literal sensory detail. That may include dampening the vividness of color. In some experiments with animals, scientists have seen flashes of brain activity triggered by colored light even when the subjects are asleep. Their brain regions still respond to changes in hue, though less intensely than when awake. This shows that color sensitivity doesn't vanish, it just gets modulated. The brain's ability to distinguish colors remains intact. It simply decides that during sleep, this information isn't critical. The broader mission of REM is to process memory and emotion, not to paint accurate scenery. So the entire system for color vision, the retina, thalamus, V1, and V4, stays online in some form. The question is why it sometimes produces full Technicolor dreams and other times just grayscale outlines. One explanation may lie in how memory and emotion guide imagery. Colorful dreams often accompany strong feelings, excitement, fear, joy, or nostalgia. Those emotions activate the same limbic circuits that color perception normally taps into. When your dream carries emotional weight, those networks strengthen and the brain colors in the imagery. When emotion is neutral or minimal, like the background of a routine dream, you might process less hue information leaving behind a muted, gray experience. Another subtle factor is attention. Even when we're awake, color perception intensifies when we focus. You notice the vibrant green of a traffic light only when you're looking for it. Otherwise, it blends into the scene. Dreaming lacks conscious attention, so unless your brain deems color relevant to the story it's telling, it might not bother to include every shade. The script matters more than the cinematography. All of this paints an odd picture, pun intended, where your visual brain keeps working even when cut off from the outside world. The result is a self-generated simulation that's still governed by the same neural laws as wakeful sight. Dreams don't bypass the color system, they borrow it selectively. What seems colorless later might not be lacking color at the moment of dreaming. It might just be that your waking memory doesn't retrieve that detail. And that brings us to one more twist in the science. When researchers study people who've been exposed to different kinds of light before bed, say blue or orange, they find that each wavelength leaves a fingerprint on the brain's activity during sleep. Blue light exposure heightens alertness and even changes how certain brain regions fire deep in the night. Greenish or amber light tends to promote deeper, slower wave sleep. What's striking is that those effects persist into REM phases, suggesting that the colors your eyes encounter before sleep echo inside the brain long after darkness falls. That persistence may subtly shape your night's imagery without you being aware of it. If your brain carries those light traces into sleep, it's not a stretch to imagine that decades of monochrome media exposure could sculpt similar neural habits. The same circuits that process hue day by day also build the visual language of dreams. When that input is drained of color long enough, the internal model might adapt accordingly. Over time, the calibration shifts. The subconscious begins to paint in shades of gray because that's what experience has been feeding it. So the machinery for seeing color has always been active, humming quietly in the background of every dream. The grayness reported by earlier generations wasn't proof of a different kind of brain. It may have been the thalamus turning down visual noise, combined with cultural and perceptual habits that prioritized form over shade. Modern imaging proves the potential for color never disappeared. Our interpretations did. That realization reframes the whole debate. Instead of asking whether people dreamt in color or not, the better question might be, when your brain rebuilds reality from memory, which details does it choose to keep? Because in the realm of dreams, color isn't guaranteed by biology. It's granted by attention, emotion, and habit. And maybe when those three align, the sleeping mind opens the gate just wide enough for the world's full spectrum to shine through. The neuroscience of color while you dream. Here's the part where neuroscience enters the picture and where things get messy. We often think of dreams as purely imaginative, detached from the body, but that's not how the brain operates. Even when you're deep in sleep, the same wiring that interprets reality by day keeps humming at night. The challenge is figuring out which parts stay active and which parts fade into silence, especially when it comes to color. Scientists face a simple but frustrating problem. You can't peer directly into someone's dream. You can measure brain waves, record activity, and even map which regions light up during REM, but you can't literally see what the sleeper sees. So every study on dream color depends on indirect clues. Patterns of activation, post-awakening reports, and in some cases, how the brain reacts to color long after the eyes are closed. Despite the limits, the data tell an intriguing story. First, there's strong evidence that light exposure before sleep leaves a chemical and electrical fingerprint in the brain. It's especially clear with blue light. Spend an hour scrolling on your phone before bed, and your brain behaves differently than if you'd read under a warm lamp. Blue wavelengths suppress melatonin, the hormone that signals the body it's time to sleep, and increase alertness. What's surprising is that this effect sometimes lingers into sleep itself. EEG recordings show distinct activation patterns in people who've recently been bathed in blue light, even during their later REM cycles, when vivid dreaming happens. The results suggest that color doesn't just fade from consciousness, it leaves a residual echo, still influencing neural rhythms while you dream. Other wavelengths have their own effects. Greenish-yellow light, around 555 nanometers, tends to promote slow wave activity, a deep, restorative sleep stage known for heavy, immersive dreams. Orange or amber light, on the other hand, promotes relaxation without delaying sleep. This means the brain doesn't treat color simply as a visual feature. It codes it as sensory energy that affects alertness levels and emotional tone. If you think of your brain like an audio mixer, each color frequency adjusts a different slider. Some boost arousal, some dampen it. Those changes can spill into the narrative texture of dreaming. A more energized pre-sleep state might translate into more vivid, high-contrast dream scenes, while softer light could yield gentler, hazier imagery. This doesn't mean you perceive the exact colors you were exposed to before bed. It's subtler than that. Exposure alters the baseline chemistry of your visual system. Specialized cells in your retina, called intrinsically photosensitive retinal ganglion cells, send signals not just to the visual cortex, but to brain regions that control circadian rhythm and alertness. Those circuits remain active even when your eyes are shut, helping set the overall tone of nighttime brain activity. It's one reason why, if you stare at bright screens too late, your dreams might feel more restless or fragmented. The visual system hasn't fully switched gears from external light processing to internal imagery generation. So what's the connection between this and dream color? Think about it this way. The machinery for color perception is still powered on, but it's running on ghost input. The thalamus, your brain's central sensory filter, continues to gate information, allowing emotional and memory-related images to pass through while dampening literal sensory data. That selective filtering helps explain why your dream may seem realistic, but also strangely muted or washed out. The brain is paying for memory using emotional cues rather than raw sensory detail. In the process, it might drop some hues to keep the emotional storyline clear. Animal research adds another piece to the puzzle. In certain studies, sleeping animals exposed to brief flashes of colored light showed measurable responses in their midbrain and visual cortex, even though they never woke up. The signals were weaker than when they were awake, but they still carried color-specific patterns. This suggests that color information doesn't disappear during sleep. It's downscaled. The brain stays color-aware, but values context over accuracy. During dreaming, where scenes morph rapidly, it may simply not waste processing power on maintaining consistent chromatic detail. Neuroscientists suspect that this selective processing relates to energy conservation. Vivid perception, especially color perception, is metabolically expensive. It takes a lot of neural coordination. Dreaming seems to focus instead on consolidating memory and regulating emotion. In that context, color may serve as an optional enhancement rather than a necessity. When your brain's emotional circuits fire strongly during intense fear, excitement, or nostalgia, it may pull those visual memory networks into full use, giving rise to saturated movie-like color. But when the emotional signal weakens, the brain economizes, leaving a dim, grayscale sketch sufficient for memory integration. Another intriguing finding involves what neuroscientists call reactivation. During REM, the brain replays patterns from previous waking experiences, almost like rehearsal loops. Visual areas echo activity from the day, what you saw, the tones, the brightness. If your daily scenes included vivid colors, those circuits replay within dreams. If your recent experiences were dominated by neutral tones, think office lighting, emails, paperwork, your reactivations may lack the chromatic punch. Essentially, your waking palette becomes the source footage for your dream cinematography. All this implies that dream color is far more dynamic than early psychologists believed. It's not either colorful or not. It's a sliding scale shaped by brain state, environment, and memory. The same person might dream in brilliant color one night and near monochrome the next, depending on stress, lighting, and sleep quality. Just as important, recall plays tricks afterward. People often fail to remember color details unless something emotional or plot relevant draws attention to them inside the dream. Without that hook, the mind reconstructs the memory in plain grayscale because it's easier. That misremembering fuels the illusion of colorless dreams. When viewed through this lens, the 20th century reports of black and white dreams start looking less mysterious. Imagine generations spending their evenings surrounded by gray films, sleeping in dim, uneven lighting, and recalling dreams hours or days later through questionnaires. Every factor, sensory input, thalamic filtering, memory distortion conspired toward muted recollection. The dreaming brain probably never lost its color. Society just stopped remembering it. We inherited our media's limitations. That realization reframes the question entirely. Dream color isn't a fixed property waiting to be measured like temperature. It's a product of ongoing negotiation between sensory memory, brain chemistry, and cultural expectation. It can't be pinned to one cause because it's distributed across biology and environment alike. The brain's color circuits, its lighting history, and even beliefs about what dreams should look like all interact to paint the final scene. So maybe the brain never turned the color dial off. Maybe it just let other priorities take over. In each REM cycle, billions of neurons juggle emotion, learning, and sensory simulation at once, trying to weave coherence from chaos. Color is optional, so it flickers in and out depending on what story your mind is telling that night. Which brings us to an uncomfortable idea. If color in dreams can fade and return depending on what our brains filter, then maybe the real illusion isn't about dreaming black and white. It's about trusting our memory after we wake. Because sometimes our recollection of a dream might quietly rewrite it, inventing color or erasing it entirely. And that's where this puzzle takes its strangest turn. The colors we think we dream may exist only in hindsight, reconstructed by a waking mind that can't stand the thought of seeing the world in gray. The memory trick that rewrites your dreams. Here's where the illusion really takes hold, not inside your eyes or brain hardware, but inside memory itself. See, dreams don't get recorded like videos. They're more like stories your brain reconstructs from fragments the moment you wake up. And every reconstruction can quietly rewrite the picture. That means the color of your dream might not depend on how you dreamed it, but on how you remember you did. Early dream studies fell right into that trap. In the first half of the 20th century, most research relied on one simple method: questionnaires. Participants were asked, "Do you dream in color?" But days, weeks, sometimes months after the dreams occurred. The answers were shaped as much by memory and expectation as by actual experience. When psychologists later compared those results with immediate awakenings from REM sleep, they realized how misleading long-term recall can be. Memory had scrubbed away details, or worse, replaced them with whatever people thought should have been there. Think of memory like an editor with the terrible habit of rewriting scenes after filming. When you wake up, your brain grabs scattered traces from the night's imagery, faces, emotions, fragments of dialogue, and reconstructs them into something coherent. But that reconstruction isn't faithful. It fills in blanks according to your expectations and the culture you absorbed. If you've always believed dreams are gray, your mind will backfill gray. It's not lying on purpose, it's just trying to make sense of fuzzy data. That's exactly what happened to early generations of dreamers. Their culture revolved around black and white imagery, movies, newspapers, photography. So when they woke and tried to remember their dreams, those visual references became the template. Their memories mirrored the dominant media of their waking lives. And because researchers asked them long after the dream had faded, there was no way to separate missing detail from invented detail. The result, entire datasets convinced scientists that human dreams were colorless. By the 196s, new tools changed that picture completely. Researchers began using REM awakening experiments, monitoring people in sleep labs, waking them mid-dream, and asking immediately what they'd seen. The results flipped overnight. Around 80% of participants described color imagery the moment they were roused. That meant the dreams themselves hadn't changed. Only the memory window had. The shorter the gap between dreaming and reporting, the more color appeared. Delay was the thief. It's easy to test this yourself. Right after waking from a vivid dream, the scene feels bright and detailed. Wait 10 minutes and the color fades. After breakfast, even the most cinematic dream becomes a washed-out sketch. Memory consolidation trades vividness for narrative meaning. The emotional core stays, the chromatic nuance drains away. We remember stories, not shades. And when later asked what the dream looked like, we reconstruct it from the story rather than sensory detail. That's how imagination masquerades as recollection. Eva Merzen's 2008 study nailed this distinction. She asked participants, both older adults who'd grown up with black and white media and younger participants raised in color, to keep dream diaries and note color immediately after waking. The diaries told one story, later questionnaires told another. The real-time notes showed plenty of color across all ages, but delayed self-reports from the same people downplayed it dramatically, especially among those with strong grayscale media memories. In other words, people weren't necessarily dreaming differently, they were remembering differently. Psychologists call this reconstructive memory. The concept is simple but unnerving. Every recall moment is also a rewrite moment. Your hippocampus doesn't retrieve a stable file, it reassembles fragments stored in various regions of the brain. In doing so, it draws on cultural context and prior beliefs to fill gaps. The more confidence you have in those beliefs, the less likely you are to notice the edits. That's why someone firmly convinced they dream in black and white will keep reporting black and white dreams, even if color occasionally slips through. Their brain filters out conflicting evidence to protect the coherent story. This isn't unique to dreaming. It's the same mechanism behind optical illusions and eyewitness distortion. We don't just perceive reality, we predict it, then retrofit our memory to match the prediction. The dream color debate simply exposes that bias in one of the most private corners of consciousness. The American mid-century dreamer, surrounded by grayscale cinema, carried that aesthetic into memory just as naturally as today's digital age mind carries high-definition visuals into sleep. Each generation recolors its dreams according to the dominant media of the day. But there's another twist. Our brains aren't just passive victims of faulty recall. They actively prefer coherence over accuracy. When facts conflict with expectation, neural networks associated with cognitive dissonance kick in, pushing us to resolve the mismatch. Reporting a gray dream when you subconsciously expect gray feels comfortable. Admitting vivid color might feel inconsistent with what you thought dreams were supposed to look like. Over decades, that comfort loop formed the backbone of a cultural myth that dreams themselves lacked color. Once a population believes something about their inner world, memory bends to enforce it. And here's the eerie part. Those misremembered details can accumulate until they shape how new memories form. The more times you recall a black and white dream, the more your brain reinforces that schema. Eventually, future dream recollections automatically exclude color even if it was there. It's a feedback loop between belief and memory. Culture sees the expectation, memory maintains it, and the myth perpetuates itself scientifically until new methods break the cycle. When modern REM studies began contradicting decades of self-reports, the shock wasn't only empirical, it was existential. It proved that our introspection can't always be trusted. We assume the mind is a reliable witness to itself, but in reality, it's an unreliable narrator. You can't ask memory what really happened. It's rewritten the moment you look. That's why two people can have nearly identical dream experiences, yet describe completely different mental films afterward. So think of it this way. The color drain wasn't a defect of dreaming. It was an illusion caused by delayed reporting and cultural bias merging inside human memory. Our grandparents' brains likely generated just as rich a palette of dream images as ours. They simply couldn't recall it faithfully after the fact, because memory is a creative act, not a playback. The same mechanism that lets you visualize childhood moments you barely remember is the one that can strip or invent color in your dream recollections. The conclusion many researchers draw is elegant but unsettling. The dreaming brain always paints in color. The waking brain sometimes forgets to see it. Each morning's recollection becomes a historical revision of the night before. In that sense, the black and white dream is one of psychology's most successful optical illusions, a trick of memory performed on yourself. And once you realize that, the whole phenomenon starts to sound less like a mystery of imagination and more like evidence of how deeply the waking mind edits reality to fit a narrative. If our memory can repaint something as personal as a dream, what else in daily life might it be quietly recoloring without us noticing? Because when it comes to perception, the final version you recall is rarely the one you actually experienced. When movies reprogram the subconscious, before color television burst into living rooms, the world most people saw on screen existed entirely in shades of gray. From the 192s to the early 195s, black and white cinema wasn't just a style, it was the visual language of modern life. Those films didn't merely entertain, they sculpted perception itself. For millions, the flicker of monochrome light in dark theaters became the most emotionally charged experience of their day. And according to decades of research, that steady drip of grayscale imagery may have done something strange. It rewired how generations dreamed. Movies are far more than pictures. They're immersive stories that fuse emotion, music, and light into one synchronized experience. When early audiences laughed, cried, and gasped along with those black and white worlds, their brains weren't passively absorbing, they were learning. Emotional arousal strengthens neural connections, embedding those images deep into the hippocampus, the same region that helps generate dream content later. Psychologically, the cinema became a nightly rehearsal hall for dreaming. The more emotionally engaged the viewer, the stronger the imprint. And when the film reel offered only shades of gray, that's exactly what the brain stored away as its visual baseline. Researchers like Eva Merzen have argued that this continual exposure acted almost like training data for the subconscious. Children who grew up surrounded by monochrome images didn't just understand stories through gray, they felt them that way. Their emotional processing, shaped by the intensity of old movies, may have linked gray tones with meaning and nostalgia. Later in sleep, when the mind reconstructs emotional memories during REM, it naturally called upon those deep visual associations. The result, dreams tinted not by the physics of sight, but by the aesthetics of memory. There's even a neurological logic to that. The same circuits responsible for recognizing emotional scenes on screen, visual regions like V4 paired with the amygdala, reactivate during dreaming. If those circuits strongest, stored templates come from black and white sources, the brain's internal projector will replay in that palette by default. The film reel of the mind mimics the one it practiced on daily. Over time, monochrome may have become the brain's shorthand for a story. It's easy to see how powerful that conditioning was when you look at cultural data. During the 194s, almost every visual narrative, from newsreels to romance pictures, was shot without color. That generation's collective imagination existed under silver light, and dreams, serving partly to digest emotional residue, naturally recycled the day's dominant imagery. Children born in that era didn't just remember movies, they internalized them as reality's aesthetics. When later asked about their dreams, they described them the only way that felt familiar, like films. Then came Technicolor. By the late 195s, color television began shifting the emotional vocabulary of storytelling. Suddenly, heroes glowed in golds and reds. The world on screen pulsed with warmth. Families gathered around their new color sets, absorbing hues that had previously existed only in daylight. Within a decade, psychology surveys showed a surge in reported color dreaming. The match was uncanny. As the public cinematic diet bloomed into full spectrum, so did their subconscious imagery. Scientists like Schwitzbüttel and his collaborators found this pattern repeating internationally. In early 200s China, groups raised on black and white broadcasts reported monochrome dreams at levels mirroring Americans from the 194s. Younger cohorts who'd grown up with color TV, however, overwhelmingly described colorful dreamscapes. Nothing biological separated them, only media history. That consistency suggests the phenomenon isn't cultural folklore. It's cross-generational conditioning built into visual memory systems. So how could movies and television reach so deep as to influence the architecture of dreaming itself? Part of the answer comes from emotional resonance. Dream formation draws heavily from emotionally salient experiences, not just random scenes. Film, especially in the early cinema era, delivered potent emotional highs, the tension of noir shadow play, the tenderness of black and white romance. Those neural fireworks help determine what material the sleeping brain revisits. Over years, repeated emotional engagement with monochrome visuals may have weighted those associations so heavily that even spontaneous dreams borrowed their tone and contrast. Another factor lies in cognitive development. Studies in visual psychology suggest that a child's early sensory environment shapes what neuroscientists call perceptual templates, default ways the brain organizes image patterns. Before age 11, those templates are especially malleable. If they are filled with high-contrast gray imagery, the system learns to treat that as normal. Later, when the child matures and begins dreaming more vividly, the brain reuses this established framework. That's why Merzen predicted and confirmed that early exposure mattered more than later experiences. Watching color movies in adulthood didn't necessarily erase one's grayscale dreaming. The foundational template had already been set. Cinematically speaking, early viewers may have inhabited a psychological half-world, emotionally vivid yet visually muted, where brightness and shadow conveyed everything that color once did. Their brains translated those patterns so effectively that color information during dreams became redundant. In contrast, those who matured amid dazzling color media considered hue itself essential for emotional storytelling. For them, dreams without color would feel incomplete. The subconscious takes its artistic cues from whatever medium taught it emotion first. Some researchers have speculated that nostalgia might help preserve these internal palettes. Older adults, especially those raised on monochrome cinema, often report recurring black and white dreams tied to memories of youth. It's not necessarily that they lost color perception with age. Rather, the brain may revert to emotionally charged imagery from formative periods, replaying them as they were first encoded. The past really does live in black and white for those who experienced it that way. Dreaming becomes a kind of neural time travel each night, revisiting the aesthetic of an earlier world. There's also a metaphorical side. Film theory long emphasized that black and white imagery invites viewers to project emotions into the gaps created by shadow and contrast. Perhaps that same mechanism operates in dreaming. A stripped palette focuses the narrative on feeling. In this sense, monochrome dreaming might not signify deficiency but specialization, emphasizing emotion over visual abundance. When color TV arrived and overloaded the senses, dream narratives may have simply adapted by matching that sensory richness. Whichever explanation you favor, emotional conditioning, developmental. Imprinting or nostalgia, the link between media and dreaming, demonstrates something profound. The subconscious is surprisingly porous. It doesn't just record personal memories, it absorbs cultural form. Every generation's dominant art medium seeps into mental imagery, shaping not just what we remember, but how we visualize meaning itself. The theater of the mind updates its visual effects library with every technological shift outside. Think of the implications today. If black and white film once made dreams monochrome, what might endless streaming, digital filters, and hypersaturated screens be doing to ours now? The same neuroplasticity that let television recolor our grandparents' imagination is still at work, quietly adapting to the hues and contrast ratios of phone screens glowing inches from our eyes. The subconscious cares less about artistic intent and more about exposure. Whatever visual world we inhabit repeatedly becomes our mind's default dreamscape. And so the age of grayscale dreaming now reads like an experiment conducted by history itself. The first half of the 20th century gave humanity a mirror test case, millions living through emotionally vivid yet chromatically stripped media. When color storytelling arrived, those same circuits simply recalibrated. The subconscious didn't evolve, it updated its software. Movies, it turns out, weren't just art. They were training manuals for the imagination. This idea bridges everything we've explored so far. Neuroscience showed that color vision mechanisms remain alive during sleep. Psychology revealed that memory can distort or erase color detail. Now culture steps in as the third element, programming the templates from which our dreams render their worlds. The borders between science, art, and personal experience dissolve into a single system of feedback loops. Each movie we watch, each screen we stare at, teaches the brain what reality is supposed to look like, even when reality is only imagined. By the time the world turned fully to color screens, humanity's dream palette had quietly recalibrated. The subconscious, forever watching, learned that stories were meant to glow. Yet before television, before cinema, dreams had always needed no such instruction. They were already vivid. To see how far the cycle turned, we need to go back in time, long before projectors and pixels, to an era when people described their dreams using colors even science hadn't yet explained. Because once upon a time, everyone on Earth dreamed in color, and they took it completely for granted. The forgotten era of vivid dreaming. Before black and white movies, before television washed every evening in gray light, humanity never questioned whether dreams had color. They just did. When ancient philosophers wrote about dreams, they described crimson robes, golden chariots, deep blue oceans, the same hues they saw every day. Aristotle called dreams the images of the waking life. Descartes, centuries later, used color as evidence of sensory truth inside hallucination. Even Sigmund Freud, writing at the dawn of the 20th century, mentioned colorful scenes as part of his analyses. He never entertained the possibility that dreams might lack hue. For thousands of years, the notion of a colorless dream simply didn't exist. Then, almost overnight in historical terms, it did. Around the turn of the 20th century, Western culture entered what researchers now call the black and white era. For reasons tied less to biology than to technology, descriptions of dreams began to lose their color. By the 191s, studies like those by Bentley were already noting shades of gray where previous generations had seen vibrant imagery. Within a few decades, the grayscale assumption became so entrenched that dreams with color felt suspiciously extravagant. When psychologists in the 194s encountered subjects who reported vividly colored dreams, they coined a slightly mocking term for them: technicolor dreams. To mid-century science, that label didn't suggest beauty. It hinted at distortion, even instability. Vivid dreaming seemed too cinematic, too indulgent. You can see the cultural logic at work. The early 190s were soaked in monochrome photography and newsprint. By the 193s, mass audiences were consuming stories almost exclusively through black and white films. The collective imagination had shifted to fit that palette. It's no wonder researchers interpreted dreams through the same lens. Psychoanalysts compared dreams to silent films, flickering, desaturated fragments of emotional narrative rather than sensory realism. The metaphor stuck because it resonated visually. Everyone's daily reality, at least in mediated form, looked just like that. Science did so much to discover colorless dreaming as inherited from its environment. But long before this detour, dreaming had been described as intensely visual, even luminous. In ancient Greek literature, dreams served as messages from the gods, wrapped in vivid imagery. Medieval mystics recounted visions of radiant light so bright it dissolves waking reality. Renaissance philosophers discussed color symbolism in dreams as naturally as they discussed geometry. None of them imagined that a dream could be gray because, for them, life wasn't filtered through gray media. Reality itself was already radiant. When they closed their eyes, the same sensory vocabulary colored their inner world. The century that followed replaced that vocabulary with monochrome. As psychology sought legitimacy by modeling itself on empirical science, researchers avoided anything that felt subjective or poetic. Measuring dream color was nearly impossible, so they dismissed it as unreliable. Their instruments could track heart rate and respiration, but not color experience. So when surveys like Middleton's in 1942 reported that roughly 70% of students rarely saw color in dreams, the conclusion seemed unassailable. The modern mind must dream in black and white. The forgotten truth was that the instruments of the time measured memory, not perception. Culture reinforced the illusion. Early 20th century magazines featured illustrations of sleeping figures beneath clouds rendered in gray tones. Movie posters equated fantasy with monochrome glamour. Even the language of psychology absorbed cinematic metaphors, dream sequences, film reels of the mind. In that environment, asking whether someone dreamed in color sounded almost absurd, like asking whether soundless movies made noise. The assumption that dreams were grayscale became self-fulfilling, shaping both research and subject expectations. Yet scattered historical clues revealed that the color never really vanished, it just left a record. Diaries from the late 180s still mention colored dreams, but by 192 they're rarer. The timing aligns not with any biological shift, but with the industrialization of image media. Technology standardized visual memory in monochrome, and the culture internalized it. Ironically, this was also the period when psychology was most preoccupied with perception. The same science that demystified color vision during wakefulness ended up ignoring it during sleep. The colorless dream was never discovered by experiment, it was constructed by assumption. Then came the backlash of the 196s. New lab methods, especially REM awakening studies, shattered the grayscale consensus. When researchers like Demen and Kahn woke participants mid-dream and asked them to describe what they saw, more than 80% reported clear color. The data didn't just surprise, it embarrassed decades of prior belief. Suddenly, the technicolor dream wasn't pathological or rare, it was normal. What had changed wasn't the brain, but the lens through which scientists observed it. The forgotten era of vivid dreaming hadn't ended, it has simply been mislabeled. When you trace this story, the irony is almost cinematic. Humanity spent millennia assuming dreams were colorful because that matched lived experience. Then one technological century convinced us otherwise, not through discovery, but through exposure. The first photographs, films, and televisions reshaped aesthetic norms so thoroughly that even researchers' imagination dimmed. Generations literally stopped remembering color because the world around them stopped showing it. As soon as the external world regained its hue through mid-century color cinema and television, the internal world followed. Reports of color dreaming surged again as if the subconscious had merely been waiting for permission to use its full palette. Looking back, the episode stands out as a humbling example of scientific mirroring. Psychologists thought they were studying the human mind in isolation. Instead, they were measuring the cultural tools of their own time, the newspapers, photographs, and movie screens that quietly programmed expectation. Each epoch's art form painted the mental image its people considered real. Before industrial media, that reality was full spectrum. The imagination had nothing else to be. Today, when we talk about rediscovering color in dreams, we're really describing a return to baseline humanity. The ancestors we picture in candlelight or marble halls never doubted that dreams glowed. Their minds didn't need calibration from television sets to imagine a red sunset or a green field. It was already there in memory. As modernity flooded life with grayscale representation, we mistook altered recall for altered consciousness. Now that science has corrected its lens, the vibrant continuity of dreaming feels both ancient and new again. So the forgotten era of vivid dreaming isn't an age we left behind, it's the original state, briefly obscured by a century of flickering shadows. Our ancestors didn't wonder whether their dreams were colored, they wondered what those colors meant. In reconnecting with that perspective, we glimpse something timeless about perception itself. That the brain's palette never truly loses its paint, it just takes its cue from whatever light the culture shines on it. The REM revolution, seeing dreams in real time. For decades, scientists tried to study dreams using only people's memories, which is a little like trying to study a movie by listening to someone describe it 3 days later. Then, in the late 195s, sleep research had its breakthrough moment, a discovery that flipped the entire field. It came down to 3 simple letters, REM. When the first researchers noticed sleepers whose eyes darted wildly beneath their lids, they also noticed something else wake them during this phase, and they could describe incredibly vivid, story-like dreams. Soon, REM sleep was recognized as the stage where the mind turns inward, replaying and remixing experience into full imaginative theater. Before this discovery, psychologists were basically guessing. Early dream questionnaires depended on late-morning recollections clouded by bias, expectation, and culture. But a handful of scientists, Eugene Aserinsky and Nathaniel Kleitman among them, pioneered a way to actually catch the dream in progress. They wired volunteers to monitors that tracked brain waves, muscle tone, and eye movement, and they woke them the instant REM activity surged. For the first time, a lab could ask, "What are you seeing right now?" instead of, "What do you remember from last week?" The answers were startlingly rich. Subjects roused mid-REM spoke of color, motion, faces, sunsets, detail on par with waking sight. When researchers like Kahn and Dement followed up in the early 196s, they found that more than 80% of these dreams contained color information clear enough for people to describe. That one shift in timing, seconds instead of hours, proved that color had always been there. The human brain hadn't evolved overnight, experimental design had. Dream science had stumbled onto its first reliable time machine, the ability to sample consciousness mid-creation rather than after the fact. This was more than a technical leap. It was a philosophical one. For almost half a century, psychology had treated dreams as ghosts of experience, wisps left for interpretation. Now the data showed measurable, repeatable patterns. REM wasn't random. Electroencephalography revealed fast, desynchronized waves resembling waking brain activity, a storm of internal simulation. If perception and imagination used the same neural highways, then REM was the moment traffic flowed purely from the inside out. Color wasn't a mystery. It was a natural byproduct of the brain running its visual circuits without input. The practical difference between REM awakenings and old questionnaires can't be overstated. Compared to photography, early studies were long exposure shots, blurry composites made long after the light had changed. REM stage awakening was a snapshot. It froze the dream while it was still unfolding. Participants didn't have time to rationalize or confabulate. They simply reported what they saw. That immediacy exposed how deceptive memory could be. People who insisted they never dreamed in color would, when awakened at the right moment, vividly describe a green jacket, a red car, or orange lamplight in the scene they just left. 10 minutes later, if allowed to drift back to sleep and recall the same dream in the morning, they often omitted those hues entirely. Memory compression erased nuance faster than science had realized. The revolution also demystified those notorious Technicolor dreams. What had seemed pathological in the 194s turned out to be perfectly typical. Researchers like Herman, Rothwerk, and Tauber cataloged hundreds of REM reports showing color frequency around 70 to 80%. In other words, humans had always been dreaming in color. The myth of grayscale dreaming was a data collection artifact. The instruments, not the brains, were colorblind. But REM studies did more than restore color. They reshaped our entire model of consciousness. The discovery showed that dreaming wasn't passive. It was active neural storytelling. During REM, the limbic system lit up, linking emotion to imagery, while the prefrontal cortex, the internal editor, quieted down. Without logic policing the narrative, the subconscious liberated its sense of color, merging hue and mood freely. That's why dream colors often feel hyperreal. They're not constrained by the calibration of waking light, but tuned by emotion itself. A sunset amplified by fear or joy, a dress glowing brighter than physics would allow. This physiological map helped bridge the cultural puzzle too. Why did post-war generations report more color once television turned colorful? Because their REM cycles were drawing from fresher, more chromatic visual memories, now measurable through real-time observation. The testable link between daily visual experience and REM reactivation explained what older questionnaires had implied without proving. The brain doesn't store a clean divide between waking and dreaming. It replays what it rehearses most. In successive nights of REM, Those replay patterns strengthen, meaning that even the cultural influence of media can leave footprints in sleep lab data. What makes REM observations compelling is their consistency. Whether in the 196's United States or later labs in Europe and Asia, the proportion of color in dreams stayed near the same high percentage once immediate reporting methods were used. That universality undercut the idea that black and white dreaming was ever biologically common. It could appear only when the measure itself depended on faulty recall. The moment science asked the brain directly by waking it mid-scene, the answer came back vividly colored every time. Yet the REM revolution carried a subtler message about perception, that inner experience obeys the same biological laws as outer vision. When fMRI scans showed activation in V1 and V4 during REM, the same regions responsible for processing hue and brightness in daylight, it became evident that color in dreams originates from genuine neural signal, not metaphor. To the brain, recalling a red object and seeing a red object aren't completely different events. They share activity patterns. Dream red and daylight red are cousins, not strangers. This insight finally connected neuroscience to the philosophical musings of everyone from Aristotle to Freud. The imagination is perception turned inward. The ethical and philosophical ripples spread fast. If scientists could monitor dreaming in real time, could they one day visualize it? Could machines translate REM activity into recognizable images? Modern neuroimaging has taken tentative steps in that direction, reconstructing coarse shapes from visual cortex data. Color remains harder to decode, but the groundwork laid by REM researchers opened that possibility. Their 196 rooms of humming equipment were the ancestors of today's dream-reading algorithms. All sprang from the same revelation, that dreaming is something happening now, not something remembered later. The shift also changed how we think about sleep itself. Far from a period of rest, REM is one of the brain's busiest times, metabolically speaking. It burns almost as much energy as full wakefulness, suggesting that generating perception from memory is hard work. The mind practices being conscious by simulating it. And the fidelity of that simulation, the depth of color, sound, emotion, is a measure of how alive the neural system remains even in repose. Perhaps the most poetic outcome of the REM revolution is what it says about the boundaries of self-awareness. When those researchers woke their subjects, they weren't just recording data. They were catching consciousness in the act of reinventing itself. Each report, hastily spoken through drowsy lips, was a frame of human creativity unfiltered by daylight. For the first time, color inside the mind had a timestamp, a pulse, a laboratory proof. That moment was humbling. It showed that the mysteries we attribute to the unconscious often dissolve with better measurement, and that our world's colors, even when imagined, obey the same circuitry as the ones we see when awake. From then on, scientists stopped treating dreams as unreliable fables and started treating them as physiological events, ones that could be examined, timed, and eventually correlated with every flicker of color we experience. So when you hear an older relative say they dream only in black and white, remember, that belief was born before this revolution. Once REM observation revealed the mind's continuous color feed, the grayscale myth could no longer survive. The dream was never colorless. Our measurement of it was. From that discovery forward, every night's sleep has carried a quiet scientific truth. The colors behind your eyelids are real, even if you forget them by morning. The psychology of belief and dream perception. Here's where the story steps out of the lab and back into the human mind, where belief and expectation can do just as much editing as biology. By this point, we've learned that color perception survives during sleep, and that cultural exposure shapes what we recall. But the final piece of the puzzle lies in how our ideas about dreaming quietly sculpt the experience itself. We don't just dream with our eyes closed, we dream through the lens of what we believe is possible. Psychologists call this the expectancy effect, and is one of the most powerful forces in perception. The moment you assume something about your inner world, your brain starts to organize sensory information to match that assumption. It's why placebo pills can relieve pain and why optical illusions work even after you learn the trick. Your mind doesn't like dissonance, it wants coherence. If you've always been told that dreams are black and white, your recall system unconsciously edits toward grayscale just to stay consistent. That's not deceit, it's neural housekeeping. Different generations have lived inside different expectations. Older adults raised on monochrome. Media developed a subtle conviction that true dream imagery should feel like those films. Flat, hazy, dramatic in contrast, but low in hue. Younger people surrounded by saturated screens assume the opposite. They describe neon streets and cinematic sunsets because that's what a real dream feels like to them. Same species, same brain architecture, totally different perceptual defaults. Culture hands down belief templates as efficiently as DNA passes down genes. Those templates don't just affect memory, they literally modulate neural activation. When subjects in imaging studies expect to perceive a particular stimulus, say a colored flash or a moving light, their sensory cortices fire in anticipation, even before the stimulus appears. Expectation primes perception. In dreaming, the same mechanism may run internally. If your mind predicts monochrome settings, it can downregulate chromatic processing before the dream even plays out. That means belief might not only rewrite recollection, but influence the dream's construction in real time. Researchers have seen echoes of this in hypnotic imagery experiments. When people are told they'll see a gray scene, their brain's color processing region, V4, shows less activity despite no external change. Conversely, suggesting vivid color boosts V4 engagement. The brain obeys its own narrative. During dreams, without an external anchor, those narratives come exclusively from the self. So if your conscious mind carries a deep cultural script about what dreaming should look like, that script could literally shape the sensory palette of your dreams. Historical attitudes reinforce this link. In the early 190s, psychological language framed colorless dreams as mature and rational, while vivid ones were dismissed as childish or unstable. That social framing encouraged people to value grayscale dreaming as the normal adult state, a mark of psychological balance. Imagine the effect of internalizing that belief from an early age. The subconscious learns not just what to report, but what to generate. Even now, older dreamers sometimes downplay color details because admitting them once signified emotional excess. Belief leaves long shadows in the psyche. Modern culture, of course, rewired those associations again. Vivid dreaming is now celebrated as creativity. Lucid dreaming communities teach visualization techniques that emphasize color intensity as a measure of control. The shift shows how plastic perception can be. A century ago, bright dreams were suspect. Today, they're aspirational. What changed wasn't neural capacity, it was context. Once society flipped its narrative, the collective mind adjusted its nightscape accordingly. You can watch the same pattern outside dreaming. Expectation modifies perception in countless lab tests. Subjects told that two identical drinks are different colors often swear they taste different flavors. When shown grayscale faces labeled with emotional words, people report seeing subtle tints consistent with those moods, angry faces appearing redder, sad ones bluer. The brain weaves sensory data and interpretation into one seamless illusion. Dreams are simply the most private version of that process, unfolding without the chance to reality check. This feedback between culture and cognition means that personal narratives become self-fulfilling. Someone who insists, "I never dream in color," reinforces that pattern each time they recall a gray dream. Their memory loop strengthens the belief, which guides the next session of perceptual construction. The brain economizes by matching prior experience rather than crafting something entirely new. Over decades, that loop becomes habit. What began as social suggestion crystallizes into genuine variation in experience. Imagery follows ideology. There's also a motivational angle. Dream reporting often carries subtle judgment, what counts as normal, interesting, or weird. Because we know dreams reveal something about us, we unconsciously censor what we share or emphasize. A person steeped in old psychological culture might have hesitated to mention bold reds and blues, while a modern dreamer might exaggerate them. The point isn't deception, it's identity. The stories we tell about our unused hours become extensions of self-concept. In that sense, dream color perception is a social performance as much as a sensory record. Neuroscience supports that interplay between attitude and activation. Belief doesn't live only in abstract thought, it recruits real neurons. Studies of expectation in sensory cortices show top-down influences originating in the prefrontal regions. When belief aligns with perception, neural noise decreases. When it conflicts, the system works harder to reconcile. That cognitive friction could explain why people rarely notice inconsistencies in their dream worlds. The brain edits on the fly, masking contradictions to preserve narrative stability. After all, coherent illusion is the path of least resistance. Once you see belief as part of the cognitive architecture rather than a philosophical add-on, black and white dreaming stops being mysterious. It's a cultural artifact produced by generations of minds seeking coherence with their environment. The mechanism that makes placebos heal or illusions shimmer is the same mechanism that once drained color from our dreams, the brain choosing consistency over randomness. What began as a learned assumption about art became a physiological habit of perception. The good news is that these habits can shift just as easily. Experiments in guided imagery show that when people intentionally visualize color before sleep, imagining red light, green forests, golden beaches, the likelihood of recalling color in subsequent dreams increases. Expectation literally repaints experience. The border between imagination and physiology is porous. Nightly rehearsal can update the subconscious template the same way media once did. This insight carries a bigger message about consciousness itself. If belief can dictate what we perceive in dreams, it's probably shaping what we notice in waking life too. Our minds filter reality through stories we've accepted without question. Color, sound, even emotion pass through those filters before reaching awareness. Change the filter, and the world changes tint. That's why the mystery of black and white dreaming isn't just about sleep, it's a reminder that human perception is never purely objective. It's a constant negotiation between the brain's machinery and the myths it lives by. So next time you hear someone claim they dream only in monochrome, don't correct them. Listen for the worldview underneath. Their dream palette might be less about neurology and more about narrative. Beliefs are the pigments of perception, and culture mixes the paint. Our inner cinema, it turns out, runs on the same principle as the outer one. The picture we see depends on the story we expect to unfold. How waking life shapes dream life. Here's where everything folds back into the present, into the screens glowing around us each night and the light pouring into our brains long after sunset. Up to this point, we've talked about how culture conditions color memory, how biology keeps the machinery ready, and how belief shapes perception. But what actually links waking and dreaming is more direct than most people think. Your daily sensory diet doesn't just influence how you feel before bed, it trains the neural circuits that will later build your dreams. The daylight you absorb, the colors that flood your phone, even the hue of your bedroom light, all of it becomes raw material for your sleeping imagination. Neuroscience calls this phenomenon sensory carryover, the persistence of neuroactivation patterns from day into night. During waking hours, every color you see leaves behind traces of brain activity that can last for hours. Regions like V1 and V4 don't simply turn off when your eyes close. They echo the frequency patterns they've been processing all day. If your evening has been filled with blue light from screens, those circuits remain overstimulated, subtly shifting how REM activity unfolds later. The result might not be a dream about scrolling TikTok, but your dream lighting could carry that same bluish tint of alertness. Studies on light exposure show this clearly. Research on sleep architecture demonstrates that blue wavelengths delay melatonin release, making the brain behave as if it's still daytime. But beyond that, EEG readings reveal how this stimulation shapes subsequent sleep. Participants exposed to intense blue light show higher frequency brain waves even during early sleep stages. That heightened arousal continues in the REM, the period of vivid dreaming. Essentially, your brain drags a bit of daytime brightness into the night, tinting the tones, sometimes literally, of your dreams. By contrast, exposure to warmer tones, amber, red, or candlelight, tends to produce slower, steadier brain rhythms. These wavelengths signal dusk to your circadian system, encouraging melatonin release and calmer neural firing. The dreams that follow often feel more fluid, less frenetic. They drift rather than jump. In that way, the color of your environment sets the emotional temperature for your dream world. A neon evening breeds hyper-real nights. A soft glow breeds gentle ones. What's fascinating is how long these effects linger. In experiments where subjects spend their evenings under differing colored lights, measurable brain differences persist well into the next morning. That persistence suggests the brain carries over not just mood, but spectral memory, the afterimage of lived color experience. It's like taking a mental photograph just before bed and developing it behind your eyelids. This connection between waking and dreaming also explains why some people consistently report dull, gray dreams. Many modern environments lack strong natural color cues. Offices bathe. Workers in neutral LEDs. Cities reflect concrete and asphalt tones. When the eyes and brain absorb limited variations, the nightly replay lacks chromatic raw material. It's not that your dreaming brain forgot how to paint, it simply has fewer swatches to choose from. The diversity of color in your waking life may predict the richness of your dream palette. That's not speculation. It's supported by circadian research linking environmental lighting to emotional resilience. People deprived of diverse light exposure show duller affect and lower cognitive flexibility. Since dreaming integrates emotion and memory, reduced stimulation during the day can blunt the imagery that night. Bright sunlight, shifting natural hues, even time outdoors, all provide neural data that the brain can redeploy during REM to create deeper, more vivid simulations. The other side of sensory carryover involves attention. Modern life fragments attention into microscopic intervals: scroll, glance, switch. That hyperfragmentation trains the brain's visual networks to flick rapidly rather than linger. The same behavior appears in dreams: jump cuts, sudden scene shifts, impossible geography. Our dreams mimic our waking cognition. They're edited at the same pace we process daily reality. So while we think of dreams as spontaneous, they're reflections of habits we practice unconsciously every day. Color perception amplifies that point. Neuroscientists have found that when people focus on detailed color tasks, painting, photography, design, they tend to report more vivid dream coloration. The act of intentional seeing hones the visual cortex, strengthening color processing pathways that later activate without prompt. Meanwhile, those who spend long hours with monochromatic text coding, reading, spreadsheet work often recount dreams described as dimly lit or washed out. The mind records its own visual priorities. Waking life writes the script, dreaming performs it. This intertwining reaches deeper with light's effect on circadian timing. The same blue-sensitive retinal cells that suppress sleep hormones also connect directly to brain regions controlling alertness and mood. If those pathways stay stimulated too late, REM cycles shift later into the night, sometimes becoming shorter. Shortened REM means less time in the vivid emotional phase tied to strong color imagery. Over weeks, that pattern can make dreams feel briefer and less saturated, not because the brain lost the capacity, but because the schedule compressed the window where color dreams happen. You're literally running out of REM time for the movie to play fully. It's a feedback system bigger than any single habit. Screens delay the onset of sleep, reducing REM. Reduced REM diminishes emotional processing. Poor emotional processing leads to restless wakefulness, which demands more screen sedation. Around and around it goes. And woven into that cycle is the slow desaturation of internal imagery. The more artificial our light environment becomes, the more washed out our inner cinema grows. That's why sleep specialists now talk about color hygiene alongside screen limits. Adjusting evening lighting, using amber filters, dimmer temperatures, or time-based color shifting helps recalibrate the brain's visual circuits. What you're doing is reminding your nervous system of the natural gradient from daylight to dusk. It's less about fixing sleep and more about realigning perception with the rhythm's evolution built in. Within a few nights of such adjustment, many people report deeper rest and richer dreams. The brain, once free from constant stimulation, reopens its theater to broader color. From a psychological angle, these discoveries highlight how thin the boundary is between conscious and unconscious perception. The same higher-order systems that misremember dream color also distort real-world memory. Each relies on top-down reconstruction, blending sensory fragments with expectation. When you spend your waking hours under lighting that exaggerates blues and flattens contrast, like most digital displays, your brain learns to interpret that spectrum as true. It then reconstructs dream imagery within the same calibration. Waking illusion becomes sleeping illusion. So if you feel detached from your dreams, or if they've gone colorless, the fix might not lie in mysticism or meditation, but in exposure. Sunlight in the morning, darkness at night, less glowing rectangle before bed. Those simple adjustments recalibrate neural timing across the optic and limbic systems, rebalancing the chemistry that turns sensory memory into dream narrative. Every correction you make to your environment feeds directly into the texture of your inner world. In the end, color in dreams isn't a separate mystery. It's a mirror of how your brain manages light from the moment you wake until the moment you close your eyes. The dream world borrows its palette from the day, flooded with artificial blues and flicker, and night will echo in electric tones. Fill it with a natural range of sunlight and shadow, and night paints with the broader spectrum evolution intended. If your dreams lie to you about color, maybe they're just reporting honestly on the world you've handed them. Because the truth is, the same neurons that watch the sunrise also write the script of your imagination after dark, and they can only paint with the light you give them. What the black and white dream mystery reveals about the brain. By now the story seems to come full circle, a strange mix of biology, culture, and memory, all conspiring to paint or drain the color from our dreams. But beneath those surface layers is a deeper point about how the brain itself works. The black and white dream mystery isn't just a curiosity of the 20th century, it's a clue to something fundamental about human perception. It shows that even our most private experiences aren't fixed snapshots of reality, they're flexible reconstructions, shaped as much by expectation as by sensation. Think of it this way, what we see anywhere, whether in dreams or daylight, is never direct. The visual cortex doesn't capture color like a camera, it interprets wavelengths through prediction. Your brain guesses what belongs in a scene based on memory and context, then fills in the rest. That same predictive process happens during dreaming, when there's no incoming light at all. The mind manufactures entire worlds from stored fragments, cross-checked against emotional cues, and presents them as one seamless reality. The black and white generations simply supplied different reference material. Their predictions were built from grayscale film stock rather than living color, so their reconstructions followed suit. This realization turns the whole debate into evidence of brain plasticity, the ability of neural systems to rewire themselves according to experience. When a person's environment floods them with color imagery, their perceptual networks emphasize hue differences. When their daily landscape is monochrome, those same pathways might quiet down. Neural efficiency, not deficiency. Over years, these subtle weightings become habits of thought. The shape of imagination reflects the pattern of exposure. Dreaming just happens to be where that principle becomes visible. You could think of dreams as nightly experiments in visual learning. During REM sleep, your brain rehearses perception itself, replaying emotional and sensory circuits to strengthen them. In that sense, the shift from monochrome to color dreaming across generations might be one of the largest natural experiments in cognitive history. Billions of brains collectively taught themselves to dream differently purely through exposure. It's proof that consciousness is a moving target, continually sculpted by culture. Neurologically, this malleability makes perfect sense. The same pathways responsible for seeing by day, retina, thalamus, V1, V4, remain active at night. But the signals that drive them come from memory instead of light. If memory favors a certain palette, those circuits reproduce it faithfully. Over time, repetition ingrains the expectation so deeply that it feels innate. The line between learned perception and hardwired perception disappears. That's what the black and white dream phenomenon reveals. Our sensory reality is an educated guess, endlessly refined by what we pay attention to. It also highlights how intertwined emotion and vision actually are. Remember that color isn't just pigment, it's feeling encoded as wavelength. Warm colors activate arousal, cool tones soothe. If a population spends decades absorbing emotional stories in shades of gray, the brain's emotional color pairing might loosen. When dreaming, where emotion drives imagery, the system reuses the associations it has. Less emotional color linkage during waking life could mean less chromatic detail in the imagination that follows. The brain saves energy by simplifying emotion in black and white. In that sense, the black and white dream wasn't a defect, but an adaptation. It was the brain aligning output with input, conserving effort by matching the world it observed. That same adaptive trait keeps modern minds synchronized with their own environments. Our brains mirror the media they inhabit, always fine-tuning expectation to the dominant imagery. If earlier generations had monochrome television, we have oversaturated digital displays. Our dreams might already be reflecting that, rendered in ultra-bright tones, jump-cut pacing, and cinematic lighting born from our screens. The principle hasn't changed, only the palette has. From a psychological viewpoint, this adaptability underscores how fragile reality can be when filtered through memory. We tend to assume experience is objective, yet every layer from color perception to emotional tone is mediated by learning. Dream research exposes that because it removes external validation. There's no shared object to compare, only introspection. When introspection shifts across decades without any genetic change, it's clear that perception is socially taught. The dream world becomes a cultural mirror, reflecting not the environment of sleep, but the collective imagination of an era. That's why the question, do you dream in color, has always been a disguised test of identity. It measures when you grew up, what you watched, and how you've learned to remember. The answer says less about physiology than about the landscape of your early mind, yet its implications stretch far beyond dreams. If exposure to black and white film could rewrite the subconscious image of an entire generation, what might constant digital immersion be rewriting today? Our memories, our attention spans, even our mental color balance, all could be drifting without us realizing it. In that view, the black and white dream becomes a metaphor for modern perception itself. It warns that our senses are negotiable contracts between biology and environment. We see what we've been trained to expect, and our dreams are that training each night. The mystery wasn't that people once dreamed without color, it's that they didn't notice the world had taught them to edit it out. Their brains prioritized narrative coherence over factual accuracy, the same trade-off that shapes every recollection we hold. So the phenomenon isn't an odd footnote of dream science, it's a symbol of how elastic consciousness really is. Perception, memory, emotion, and culture form a loop, each rewriting the other in slow feedback, until what feels natural is just what's been reinforced most. Dream color became the currency of that loop, flipping in tandem with technological change, proof that the human mind doesn't simply experience the world, but adapts its sensory model to match it. And maybe that's the real revelation waiting behind those faded dreams, that the brain paints reality with borrowed light. Whether it's the glow of a movie projector or the blue of a phone screen, whatever pattern we stare at long enough becomes the palette of the self. Dreams only expose it because in sleep, there's nothing left to distract from the projection inside. The black and white generation wasn't dreaming differently. They were witnessing the brain's most basic principle in action. Perception is prediction, and prediction is history remembered as sight. In the end, this tiny mystery about dream color points to something immense about being human. Our inner world is editable. The same neuromachinery that reconstructs last night's visions also reconstructs today's memories and tomorrow's expectations. Every color we recall, every story we absorb, every image that flickers before sleep becomes part of that reconstruction. What the black and white dream mystery really teaches us is that consciousness is never static. It's a living film, constantly reshot, relit, and recolored by culture, biology, and belief all at once. The real dream lie. So after all this, here's the twist. Your dreams aren't in black and white or color. They're in memory's imagination. Every night, your brain builds a movie from scratch, powered by circuits that never stop seeing. But when you wake up, the part that remembers that movie starts rewriting it. The result isn't what you saw, it's what your waking self can still make sense of. Dreaming in gray or color isn't about vision, it's about recollection. Neuroscience has made that clear. Even in sleep, the regions that decode hue, V1, V4, and the thalamic relays stay active. The mind doesn't turn its eyes off, it just shifts from external to internal light. What fades is precision, not capacity. When people swear they dreamed in black and white, the real loss wasn't pigment, it was retrieval. The subconscious had all the colors, memory lost the file. You could picture consciousness as a painter that never stops repainting its own work. Dream color is one of its test strokes. Each generation's palette shows what the collective imagination was fed. The early 190s lit their nights with silver film. They dreamed in silver. Later, the world glowed through color screens, and minds followed suit. Something as simple as television ended up steering how billions of brains described their private worlds. That's how porous awareness really is. But the deeper truth is this: there's no objective version of a dream at all. When the mind conjures and remembers at the same time, there's no original image to compare, only the story you rebuild. And because that rebuilding uses the same circuits that shape waking memory, the line between outer and inner experience dissolves. The colors you dreamed are the same colors you invent when you recall an old beach trip or visualize a song lyric. Reality, dream, and memory share the same paintbrush. That realization pulls the mystery far beyond sleep. It means everything we think we see in daily life is equally reconstructed, a best guess woven from expectation. The black and white dream myth is only the most obvious clue. We believed in it collectively, produced data to prove it, then disproved it with better tools. The experiment never ended. It just moved from labs to living rooms. Screens, algorithms, and light now program the palettes we'll dream with next. So what does that make a dream? Not evidence of another world, but a nightly reflection of this one. Filtered, remixed, remembered wrong, yet emotionally true. If we could somehow record the raw neural footage before memory edits it, every dream might blaze with impossible color. But because we wake and narrate, most of that light gets replaced by language. Words are gray instruments. Memory is a grayscale translator. We turn luminous chaos into coherent outline, sacrifice saturation for sense. And maybe that's the final lie our minds tell. That what we recall must be what was real. The science says otherwise. Consciousness is a story factory, rebuilding yesterday and inventing tomorrow with the same set of neurons. Whether it's a crimson sky over a dream city or a black and white chase through memory, the image only exists at playback. Your dreams never lost their color. Your waking mind just prefers a simpler version. So tonight, when you drift off and the inner screen begins to glow, remember that what unfolds isn't fixed film, it's live editing. Color is still there, waiting between neurons, ready to bloom the moment belief allows it. The real revelation isn't that your dreams change with history. It's that perception itself always has. The mind doesn't record reality, it reconstructs it. And the world you see, awake or asleep, is only as vivid as the imagination you let it borrow.